Welcome to BobMath. In this video, we have a new exercise for algebra. Well, our exercise is as follow. We have x, y, and z as a definitely positive real number. So show that x squared divided by y plus y squared divided by z plus z squared divided by x greater than or equal x plus y plus z. Before discussing the solution, try to complete the exercise to increase your skill in mathematics, then complete the video. Okay, we know that x minus y square greater than or equals 0. So x square plus y square minus 2xy greater than or equals 0. Therefore, x square plus y square greater than or equals 2xy. We also have it y greater than 0. So 1 divided by y greater than 0. So 1 divided by y times x square plus y square greater than or equal 2xy times 1 divided by y. Therefore, x squared divided by y plus y squared divided by y greater than or equal 2x. So x squared divided by y plus y greater than or equal 2x. So x squared divided by y greater than or equal 2x minus y. So we call this inequality 1. And in the same way, we show that y squared divided by z greater than or equal to y minus z, and z squared divided by x greater than or equal to z minus x. We call this inequality 2, and we call this inequality 3. Therefore, we add these inequalities 1, 2, and 3 side by side. So we got x squared divided by y plus y squared divided by z plus z squared divided by x greater than or equal to x minus y plus 2y minus z plus 2z minus x. Therefore, x squared divided by y plus y squared divided by z plus z squared divided by x greater than or equals x plus y plus z. Therefore, this is the relationship required in this exercise. So thank you for watching, and please don't forget to subscribe to my channel for more exciting videos.